Hello guys, how are you all? I hope all of you are fine. So please don't go anywhere. Please stay in home. Take care of your health. Okay. So in the last video, we discussed the slice-based testing. So so in the model 3, so as I already as I already explained you regarding that one, we have different parts, right? Three parts. In the first part, we encounter the statement testing, branch testing, and all. The second part, mainly consisting of path-based testing and data flow testing, right? But this is actually the third part, right? In the third part, it mainly considering the aspect of execution of test execution. Okay, so let us consider how to execute the test cases. What are the supporting structures you know uh, needs to be framed to execute the test cases. Okay, so let us see the learning objectives. Appreciate the purpose of test automation, right? We should know the purpose of test automation, right? Test automation in the sense, when you are executing the test cases, here we are more concentrating on the automation of a test cases, as automation. Okay, instead of manually executing the test cases, there may be some automation program. If you execute the program, that in itself execute the test cases. Okay, so the main idea is to factoring repetitive mechanical task from creative human design task in testing. Okay, this is the main idea. Factoring repetitive mechanical tasks, right? Because these are same thing. If you are assigned as a tester, or if you are responsible for executing a test cases, you need to execute the test cases every day. For the same product. Okay, instead of that one, what you are going to do, uh, you will write some scripts. That scripts contain some test executions. So if you run that scripts, that serves as a test as automation. Okay, I recognize main kinds of components of test scaffolding. This is the second learning objectives we're going to learn in this part. Okay, what is actually the scaffolding and all. Okay, understanding some key dimension in test automation design. What are some key dimension in test automation design? This also we're going to see. So under this one, we have design for testability, controllability and observability, degrees of generality in reviews and steps, comparison based oracle, and self checks. These are all some learning updates. Okay, let's see what exactly the automating test execution is. So designing test cases and test shoots is creative, right? When you are actually designing the test cases as well as test shoots, is actually considered as a creative way. Like any design activity, a demanding intellectual activity requiring human judgments. Okay, it's designing test cases and test shoot is actually a creative thing, right? So like any other design activity, this is also one of the design activity, and also it demands the intellectual activity. Okay, it demands the intellectual activity as well as it requires the human judgment. Okay, so executing test cases should be automatic. Okay, design one, because when you're executing test cases, it is considered as an automatic way. You actually design once the scripts. You are going to execute that scripts. You're going to write the scripts only once, and you're going to execute the same scripts many times, so that of course it will save the time. Okay, so the test automation separates the creative human process from mechanical process of test execution. Okay, so Test automation separates the creative human process from the mechanical process of a test execution, right? Yes. So this test automation actually separates a creative human process from the mechanical process from test execution. So compare when you executing a test manually. So what actually you're going to do? So manual going to give command and you're going to execute the test. You're going to do the same thing day by day, every day you're doing the same thing, right? It's something like mechanical work. But when you conduct the test automations, this actually separates a creative human. So while writing a scripts, he may be a creative. He may actually follow different approaches, so that while writing a programs, of course, the person definitely he will think in a creative way. That's why it will separates a creative human from mechanical process. Okay, that is the advantages of automating the test execution. Okay, so here in the next slides we're going to see generation, some from test case specifications to the actual test cases. Okay, test design often yields test case specifications rather than concrete data. Right? This test design actually often yields a specification of test case rather than concrete data. For example, a large positive number. Right? We write a large positive number, not something like 420023. A large positive number is some kind of specifications. While writing 420023 something like concrete data. Of course, there is a, even though the two are same, while writing the specification is more specific than executing writing the actual number, right? So another example is sorted sequence length is greater than 2. Okay, here also it's a specification. You're not writing something like not something like alpha, beta, chi, omega, and all. A sorted sequence, it's actually less the length should be actually less than 2. This is some kind of specification. Okay, so other details for executions may be omitted, only the required the execution only considered. Other details of execution may be omitted. So generation creates concrete executable test cases from test case specifications. So this generation actually creates a concrete executable test cases from test case specifications. This is actually the use of the test cases. Okay. Coming to the example tool chain for test case generation and execution and all, we could combine a combinatorial test case generation like genpaste dot py. Okay, py is nothing but Python. Okay, the combinatorial test case generation to create test data as optional is not a mandatory. It's optional tool. This constraint based test data generated to concretize individual values. Example from positive integer to 42. Right. So data steps to convert from spreadsheet data to JUnit test cases. So some JUnit will come. So here some tools we going to use. Some tools actually have been used here. So these are all the unit of names of that. Okay, data steps to convert from spreadsheet data. So instead of using a spreadsheet data, they convert the spreadsheet data to JUnit test cases, so that it's actually executed in a JUnit. Okay, JUnit to execute concrete test cases. Okay, these are all different method. So many other tool chains are actually possible depending on the application tool. Okay, these are all some example of a test case generation and execution. So next one, Here another important concept will come, that is called what? Scaffolding, right? What is scaffolding? The name only tells you, right? The you know, image, the picture in this slide only tells you what exactly the scaffolding, something like supporting structure, right? So code produced to support development activities, especially testing, is called actually scaffolding. So this code is actually produced to support development activities. So when actually constructing a building, they use some supports, right? The support is called scaffolding. In the same way, they use some sort of code. Okay, this code actually produced to support the development activities, especially during the testing. So this is called scaffolding. Okay, so not part of the product. Okay, of course it's not a part of the product, or it's not a part of the program. This just provide a supporting structure. Okay, as seen by the end user. Okay, of course when final end user actually not able to see this scaffolding. Okay, maybe temporary, of course it's maybe temporary, like scaffolding in construction of building, right? It's maybe a temporary, right? And this scaffolding includes test harness, drivers and steps. Okay, these are all the three important units of scaffolding: test harnesses, drivers and steps. Okay, what exactly scaffolding means is something like a supporting structure. When developing a code, it will support the code. Okay, it just acts as a supporting for a code. It may not be useful for it actually not available for the end user. It during after completing the product, this scaffolding will be removed, and in the final product will be delivered to the uh, actual end user. Okay, so the main structure of the main components of scaffolding are test harnesses, drivers and steps. Okay, let us discuss different parts of scaffolding. Okay, the first part is test driver. So when you heard the term test driver, always remember it's something like main program. Okay, it's a main program for running a test. You want to execute a test cases, right? When you want to execute a test cases, of course it will start from main program. So this test driver serves as a main program. So maybe it's actually produced before a real main program. It's maybe produced before a real main program. Real main program is there, right, for every execution. For example, for a product, a real main program is there. So before producing that one, this real main program may be constructed. Okay, this test driver provides more control than the real main program. Of course, uh, since it's a scaffolding structure, it will support the code. It actually controls the entire program, entire program than the real main program. I mean to say, it actually, this test driver is considered as a powerful tool, powerful main program. Okay, what is stubs? This stubs, it is serves as a step substitute for called function. Okay, it is something like substitute for a called function, right? When a main program is there, when other functions are different function, different units are there, right? One function may call main program, or one function may call other program, other function may call another program. Okay, one function may call another function, in terms that other function can call another function, right? So when you of course when you're executing, when you're writing the program, of course one program may call another program, right? In main program also, there may be a different function that may call another functions. Okay, so this test steps serves as a substitute for the called function. Instead of calling the actual functions, uh, this will consider as a substitute for that function. Okay, for example, when you are watching any movies, so when a hero actually making any stunts, right? Of course, some heroes like Akshay Kumar and all, they will do their own stunts. But other heroes considered, the newcomers and all, instead of doing the stunts, by the main hero, by the particular hero, the other stuntman is considered as a dupe for him. So instead of you know doing the stunts by the main, the real hero, the dupe or the other stuntman actually actually do the action sequences. So this dupe for the hero is considered as a what? The duplicate. Or in this case, this steps to the same purpose. Instead of calling the exact functions, this will be substituted. So this will be called. This will serves as a dupe for the main dupe for the functions. Okay. What is test harness? Test harness is nothing but substitute for other parts of the deployed environment. So this steps actually serves as a what? Substitute for the other functions, where this test harness acts as a substitute for other parts of the deployed environment. For example, other parts is nothing but the software simulation of a hardware device. A hardware device is there. So see, if you want to check the simulation of that particular hardware device, you're going to do the simulation. Simulation is something but instead of doing the real thing, this real thing word actually actually represented in the form of a software, right? And represented in the form of a software simulations. So instead of doing the exact thing by a computer robot before its actual implementation, that will be simulated in a computer by the software. This is called software simulations. So this harness actually considered as a substitute for the other part of deployed environment. In this case, the software simulation, right? So even though the software simulation is not real, it is actually computer generated thing. What actually the real robot will do, that will be simulated in a software. When you're actually doing network simulation lab, right? NS2 and all. So instead of the actual instead of sending the actual packet to the network, you will simulate the same process in a program. This is called network simulation. That network simulation is also an example for this test harness. Okay. So regarding the controllability and observability, is something like control, how the controllability observability is come. For example, we want to automate tests, okay, but interactive input provides simulated control and graphical outputs provides limited observability. So in this case, what we're going to do, the graphic user interface input, for example, a music controller is actually connected to the program functionality. I mean, it logically connected to the program functionality. In terms, this program functionality in terms is connected to the graphical output MVC. Okay, this is some kind of controllability and observability view. Okay. It same way, if you relate to the disk drivers, the disk drivers also in terms connected to the log behavior. So this log behavior will be captured in the wrapper by the graphical output, MVC view. Okay. A design for automated test includes provides interfaces for control and observation. Okay, something like wrapper and output. Okay. Coming to the different types of scaffolding, right? There are two different types of scaffolding will come. Okay, one is generic, another one is specific. So how general should scaffolding be? what exactly the general scaffolding means. So we could build a driver and steps for each test case. Okay, for each test cases we could build a driver and steps. So or at least factor out some common code of the driver and test management. Okay, for example in JMU, or further factor out some common support code to drive a large number of test cases from data, as in TT steps. Again, you can generate the data automatically from a more abstract model, example network traffic model. So these are all general way of doing the scaffolding. What is the first thing? We could build a driver and steps for each test cases. That is one approach. In another approach, at least we can build some common code for the driver and test management. A common support code to drive a large number of test cases, again to generate a data automatically from a more abstract model. Okay, these are all considered as a general scaffolding. Okay, question of cost and reuse will be coming to the picture when you are using the general scaffolding, just as for other kinds of software. Okay, what exactly the specific means, right? So we know exactly the general scaffolding. Right? General scaffolding means how we can generally do the things. What exactly is specific scaffolding